Good day, my name is Monique Jackson. Welcome to our APDS project walkthrough. I'm the main backend developer for this project, so that'll be my area of explanation.
Hello, my name is Malerato Siboni and I will be focusing on the security measures we've implemented in the application.
Hey, I'm Saleh Adams and I'll be walking you through the front end of the application.
And I am Imran Ludovic. I'll be focusing on the testing we've deployed in the application. For our APDS POE assignment, we were instructed to create a payment system that employed good security measures as stipulated in the rubric and taught to us in our APDS module. The app was developed using MERNStack, which incorporates MongoDB as its database, Express.js, which is a Node.js framework that simplifies writing the backend code, React for designing and creating the front-end UI and components, and lastly, Node.js, which is an open-source JavaScript runtime environment that allows us to run the application server.
To set up the project, you'll need access to the GitHub repository. Our repository is public and the link to our repository can be found in our project's README. The next step you'll need to do is clone the repository onto your local device. Once the repository is cloned, you might be prompted to install some dependencies. In the backend directory, where server.js is located, run npm install to install the necessary dependencies, including Express, Mongoose, Express Session, bcrypt.js, Express Validator, Express Brute, Helmet, and Cause.
If this were a normal project where the security wasn't for testing purposes, we would have instructed you to set up environment variables. You would do this by going to the root of your backend project and creating a .env file. You would have needed to set up the necessary environment variables such as the database connection string. You would have needed to replace the MongoDB URL and the session secret with the correct values for the project. However, since the security module needs to have some odd security for testing, the connection string and the secret keys are out in the open for view. Should they for some reason not be there, they are also stored in the README file.
Next, you'll need to start up the server. To do so, navigate to the backend path in the project folder. Copy the path that holds the JSON file. In the terminal, type cd and paste the copied path. Once the path has been loaded, give the prompt node server.js. This will start up the server on the default port 5000. You can access the API at this link.
To run the application, first you'll need to have Node.js installed on your machine. Next, you'll need to install the front-end dependencies. Repeat the process of copying the file path, only this time copy the file path that leads to the front-end folder where the JSON is stored. To install the required dependencies, write into the terminal npm install. To start the application, using the same front-end path, write into the terminal npm start. This will start the application on the 5001st port, accessible at https localhost 5001. Copy that link and paste it into your Firefox browser for the best app experience.
When you have pasted the link for the first time, Firefox will pop up with a warning. Scroll down and select the Advanced Security and select to trust the link.
The first of the app features are registration and login form, which I will give you the steps to follow to interact with. For register, only the application's clients can register to create an account. Employees are made externally. You need to fill in the username, password. first name, last name, ID number, and account number fields, and then click Register to create a new account. After a successful registration, you will be redirected to the login page. The login page is for both clients and employees. To log in as a client, use your username, password, and account number to log in. To log in as an employee, use your username and password to log in. If successful, you'll be logged in and redirected to the home page. Because there are two types of users, there are two types of interfaces. We'll discuss the client users first. The client homepage shows a summary of the user's account, including their balance and recent transactions. It also displays a welcome message with the user's name if they are logged in, and an option for the user to create a transaction. There is also a nav bar, which allows the user to navigate to home, to make a transaction, or to log out on any screen. By selecting the Create a Transaction button, the user is navigated to the transaction page. Here, the user can create a transaction by filling out the required fields, including the name of who they are sending the transaction to, their own account number, the amount of money they wish to transfer, the currency type, and the transaction method. If the user selects the SWIFT option when selecting a transaction method, they will be required to enter a SWIFT code. If you log in as an employee, the homepage will present you with the following: a banner that greets the user with welcome and their username, a selection summarizing your account information, including your current balance and the number of pending transactions, a list of recent transactions with details such as receipt, amount, status, and date, and an additional button for employees to view and approve pending user transaction. It also includes a button that allows you to navigate to the page for creating new transactions. Employees can select the transaction list button. This will navigate them to the transaction list, where they will see all the transactions that need to be sent off. Employees can view the transactions, approve them, and send them off. Finally, both client and employees can log out of the application.
The application uses API to write data to and read data from the database. Previously, all our code made use of Axios as a front-end endpoint. However, Monique, found them confusing. So I made use of the old tried and tested method of writing out the whole post methods to get the data from the user entered into the application. This image shows the front-end API post methods for registering a client. It converts the data into a JSON format and sends that to the back end. This also allows for cookies to be sent. In the front-end JSON file, it sets the port, which is port 5001 for the front end, as well as sets up a proxy for communication between front end and back end, while setting the proxy to 5000, which is the back end port. This front-end API talks to CORS, which acts as a communication point between the front end and the back end ports.
Here is the root or controller for the registration. The data gets validated before they can enter the database. The validation includes username must be alphanumeric characters and underscores 3 to 20 characters long. Password at least 8 characters, including at least one letter and one number, and a special character that's an exclamation mark. First name and last name must be letters. ID number, exactly 13 digits. Account number, 8 to 12 digits. Once the data has been passed the validation process and the password gets hashed using bcrypt, it gets sent to the database.
Of course, for this process for the user to be created, we need a user model. The user model houses all of the attributes pertaining to the user that can be saved into the user table. The user models is also used when the user logs in. The isEmployee attribute is set to true when an employee is made and set to false when a client is created. Because there are two types of users that can log into the application, and one of that users is an employee who doesn't need an account number. The account number isn't an overall requirement for logging in. For both clients and users, the passwords they entered are cross-referenced with what is stored in the database. When a user logs in, a session is made. These cookies carry the user's information that can be used later, like when the client creates a transaction. When a client creates a transaction, its front-end endpoint is the same old school post method. After filling out the necessary data, when the data reaches the controller or root, it gets the user ID and account number through the cookie session, and only once those are added and verified will the data get sent to the database.
When validating a Swift code during a transaction, the code needs to follow specific rules. The first four characters should be uppercase letters representing the bank's code. The next two characters must be ZA, indicating South Africa. The following two characters should either be letters or digits 0 to 9. And the last three characters, if present, can be letters or digits representing a specific branch of the bank.
When an employee sees a list of transactions, the client account number has already been verified and cross-checked using the cookie, and the Swift code would have been verified as well. All the employee needs to do is manually check, approve the transaction, and send it to Swift. Lastly, here's the code for the users logging out.
Next, we're diving into the important security measures we've implemented in our banking application to protect customer data and ensure secure international payments. As you can imagine, handling sensitive information like account numbers, passwords, and transaction details requires a high level of security. So, let's break down the key measures we've taken to keep everything safe and sound. First up, let's talk about password security. We know that passwords are one of the most common targets for attackers. So, to ensure that the customer passwords are protected, we've used bcrypt for hashing. This means that even if the database is compromised, attackers will only see scrambled values instead of plain text passwords. Bcrypt uses a special algorithm to hash passwords, making it computationally expensive to guess the original password. This way, even if someone tries to breach the system, they won't easily crack the password hashes. Now, onto CORS, or cross-origin resource sharing. This is a key measure to prevent unauthorized access to the back end from other websites. By configuring CORS, we only allow requests from our trusted front-end application. This helps protect sensitive data from malicious sites that might try to interact with our backend without permission. As you can see here, only requests approved domains are allowed, while all others are blocked. This prevents unauthorized access and helps secure the application. Next, let's talk about Helmet. Helmet is a great tool for setting up HTTP security headers that protect against common vulnerabilities like cross-site scripting and clickjacking. It is an extra layer of defense to make sure that your web application is as secure as possible. Helmet sets critical headers like content security policy, which restricts what content can be loaded on the page. Reducing the risk of malicious scripts, it also sets X-frame options, preventing the app from being embedded in malicious iframes. which helps defend against clickjacking attacks. Finally, it reinforces strict transport security to ensure that all communication is done over HTTPS, making it much harder for attackers to intercept data in transit. Speaking of HTTPS, all communications between the client and the server are encrypted using SSL certificates. This means that any sensitive information like passwords or payment details is securely transmitted over the internet. SSL certificates encrypt the data so that even if an attacker intercepts the communication, they won't be able to read or tamper with the information. Usually, these certificates are kept from user eyes and stored in protected places. However, due to the nature of this module, the certificates are out in the open and are available for viewing pleasure.
I'll be continuing from here. We've also implemented rate limiting using express rate limit, which limits the number of requests a single IP can make in a given time period, specifically 100 requests per 15 minutes. This helps mitigate the risk of denial of service attacks, where an attacker tries to overwhelm the system with traffic. With rate limiting in place, attackers are prevented from flooding the system with requests, ensuring that resources remain available to legitimate users. Another important measure is brute force protection. Using Express Brute, we've limited the number of failed login attempts to 5. If someone enters the wrong credentials 5 times in a row, their account is temporarily locked. And this prevents attackers from repeatedly guessing passwords, which is a common tactic in brute force attacks. Then there's input validation. We've built checks into the backend to make sure that all user inputs, whether it's a password, an ID number, or an account number, are in the correct format before they're accepted. This helps protect against injection attacks and ensures that the system only processes valid data. Finally, let's talk about session management. The user session is managed via a secure cookie called user token. This cookie has several important attributes that help protect it. First, the HTTP only attribute ensures that the cookie cannot be accessed by JavaScript running on the client side. The secure flag ensures that the cookie is only sent over HTTPS, and the same site attribute restricts how cookies are sent with cross-origin requests. Together, these attributes help prevent session hijacking and ensure that users' sessions are secure.
Testing login API on Postman or post/API/login. Create another post request and add this. In the body tab, choose raw and set the format to JSON. Add the following JSON to log in. For testing purposes, we will be using the credentials from the previous registration step. Hit send. If successful, you will get a response like this. Upon a successful user login via Postman, the response will also include a session cookie. You can expect the cookie in the Cookies tab of Postman. Next, we will test the Transaction API or post/API/transaction. To test this Transaction API, we first need to ensure that the user logged in either from the front end or the login API. Now, create a post request at. In the Headers tab, ensure to add a cookie you've received from the logging response. In the Body tab, set the content to raw, select JSON, and add the transaction body. Hit send. If successful, you will get a response like troubleshooting common errors. First error, 404 not found. This means the route you're trying to hit doesn't exist or is incorrect. Double check the route you're hitting, for example, /API/login or /API/transaction. Make sure that the server is running on the correct port. In this case, it would be localhost 5000. Error 2, 400 bad request. This usually happens if the data you're trying to send in the request doesn't meet the validation criteria. For example, the password doesn't have at least 6 characters or the username is an invalid format. Error 3, 500. This usually happens when there's an error with the connection to the server. Usually this means that the server isn't running, so the data cannot be sent to the database. The employees of this application were created through Postman. Like with the normal registration testing, the user data gets entered, only this time the account number isn't included and the is employee attribute is set to true.
MongoDB was our database for this module. We had a database named test and two tables within it called users and transactions. For the sake of this project, our database that should have been secured is available for viewing from any IP address.
Next, I'll walk you through how I integrated SonarQube, specifically using SonarCloud, into a Circle CI pipeline for the existing GitHub repository. This setup allows us to automatically scan our code for hotspots and code smells, making it easier to track and address potential issues as the project evolves. First up is setting up SonarCloud. SonarCloud is a cloud-based version of SonarQube, making it ideal for quickly adding code analysis to a GitHub project without the need to install and manage a server. Once signed up, I had to link SonarCloud to my GitHub account and selected the APDS7311 repository to scan. After setting up a new project in SonarCloud, there are a few variables that I needed for integration. First, a Sonar token is needed to be generated. This token authenticates SonarCloud's access to the repository for analysis. Alongside this token, we use Sonar Project Key, which identifies the specific project in SonarCloud. And finally, Sonar.org, which refers to the organization in SonarCloud. Next, we head over to our Circle CI configuration file in the GitHub repository. Here, I'll add a job that uses the SonarCloud scanner. And this job needs our SonarCloud environment variables, Sonar Project Key, Sonar.org, and Sonar Token to properly authenticate and identify our project. Since we're using both GitHub and GitLab for version control, GitLab is also set up for automatic reporting. I configured the GitLab CI/CD settings to run the Circle CI pipeline automatically whenever we push to the main branch. This triggers the SonarCloud scan and uses the three variables Sonar Project Key, Sonar.org, and Sonar Token for accurate identification and reporting. Once everything is configured, any new code changes will automatically trigger the Circle CI pipeline. Here, you can see the pipeline running. The Sonar scan job checks the code against SonarCloud using the identifiers and tokens to authenticate the project and organization. After the pipeline completes, the SonarCloud report will provide detailed feedback. Here, SonarCloud has flagged certain parts of the code with hotspots or code smells. Hotspots are areas that might lead to vulnerabilities, while code smells indicate poor coding practices that could impact maintainability or readability. Each issue has a description with suggestions for improvement. For example, if SonarCloud detects a potential security vulnerability, it provides detailed insights and recommendations to fix it. Similarly, code smells might suggest refactoring options for better efficiency or readability. Based on SonarCloud's feedback, I reviewed each flagged area. I refactored parts of the code to improve readability and removed unused variables to clear up some of the code smells. For identified hotspots, I reviewed the security recommendations and made adjustments as needed to enhance the code safety.
And that's our video. This has been Monique Jackson.
Malerato Seboni.
And Imran Ludwig. Thank you for watching.